Hello everyone, I'm Alicia Sakya, currently studying Masters in STEAM Education from Kathmandu University School of Education. Today I'm here to present my presentation on the topic chi-square test in analyzing categorical educational data. So moving towards another slide. So what is chi-square test? So chi-square test is a fundamental statistical method designed to examine the relationship that exists between categorical variables. So it is a primary test used to analyze two categorical variables. It cannot be used to analyze purely numerical data like age, height, and weight. It works by comparing what you observed, like from your actual survey results, against what you would expect to happen by random chance. Now moving towards next, what is chi-square test? So chi-square test provides a framework for understanding how different groups or categories might be associated. For example, if you are going to investigate whether students prefer online or traditional face-to-face learning environment significantly across different educational levels. Or you can also say you have to investigate students' preference in online or traditional face-to-face class regarding the educational subjects. Okay, so this is just a one example. Now understanding about the categorical data. So before I have mentioned that in chi-square test you have to use categorical data instead of purely numerical data. So what is categorical data? So, categorical data in general term is the general term for data that represents groups. Okay, so categorical variables classify data into distinct groups or categories. Nominal data and ordinal data are the two types of subgroups of categorical data. In chi-square test, technically both nominal and ordinal data are used, but it's more appropriate and commonly used for nominal data. So, for example, in an educational context, these could include classifications such as students' gender, their current educational level, or the specific type of course they are enrolled in. Now, moving towards next, so types of chi-test or chi-square test. Okay, so there are generally two types of chi-square test. One is chi-square test goodness of fit and another is chi-square test of independence. So chi-square test goodness of fit checks if your sample data matches the distribution of the whole population. So in general, it helps to analyze if there is any differences between the expected frequencies versus the calculated frequencies. Okay, so this is the type of chi-square test where it checks if your sample matches the distribution of the whole population. Now another type of chi-square test is called chi-square test of independence, which checks if two variables are related to each other or not. So it helps to analyze if there is a relationship between or if two variables are if two variables have significant with each other or not, or they are significant with each other or not. So it checks if two variables are related to each other or not. So for example, does the student's gender affect their choice of subject, or does the student's gender affect the educational level? So you can use this test to check if two variables are related to each other or not. Now moving towards next, how is it performed? So how chi-square test can be calculated? So I have listed stepwise instruction on how to calculate the chi-square test. So first step is to create your hypothesis. So here I have created two hypotheses. One is null hypothesis and another is alternative hypothesis. So null hypothesis says there is no relationship between the variables, whereas the alternative hypothesis says there is a significant relationship between the variables. Now second step is to collect your observed values. Okay, so observed value is the actual data you have gathered from the survey or experiment. And third step is to calculate the expected value. Fourth step is to calculate the chi-square test using the formula. So here I have mentioned the formula, which is generally the square differences between observed and expected frequencies divided by the expected frequency for each category. And step 5 is to check for the significance. After you get the chi-square value, you have to check for the significance. So you have to compare your calculated results with the critical value, which is 0.05. So if your result is higher than the table value, or if your p value is less than 0.05, you will reject the null hypothesis. So this is how you can perform chi-square test. Now moving towards next, I have shown one picture over here, which is based on the picture of Jamovi. So you can also calculate chi-square value using Jamovi. So I have listed a small instruction over here. Like first you will go to Jamovi app, then you will click into the analysis parts, then to frequencies, then into rows and columns you are going to enter the variable, and after that you are going to find the value of chi-square test. So first you can calculate the chi-square test using Jamovi. I will show you in a while how to obtain the value, or how to obtain the result of chi-square test using Jamovi. But the important part that I have included is, if your value is less than 0.05, it will reject null hypothesis and the result will be statistically significant. If your p-value is greater than 0.05, then it will not reject null hypothesis. That means the result is not statistically significant. So this is the important part where uh, you are going to interpret the results based on the value of the chi-square. Now I have opened the Jamovi. This is the like sample data that I have created. So this is the sample data that I'm going to use to calculate the chi-square value of different variables. So this is the sample data that I have collected. Now let's move on to find the chi-square goodness of fit. So first you are going to go in this analysis portion. Then here you are going to go with the frequencies. After going to the frequencies, you can find chi-square goodness of fit over here. So you are going to click chi-square goodness of fit over here, and this tab will be open. Now in this variable, you are going to put the variable. For now, I am going to use university role as my variable. So as you can see over here, you can find this chi-square goodness of fit table over here. So as you can see, the p-value is less than 0.05. So it rejects the null hypothesis over here. So like this, you can find the chi-square goodness of fit value from Jamovi, using the Jamovi. Now I'm going to show you how to use chi-square test of independence. Okay, so first you are going to go to the analysis portion, then you will find click the frequencies over here, and in after clicking the frequencies you will see there is the chi-square test of association. So you are going to click on this independent samples, and this tab will be open. So for the chi-square test of independence, I am going to use two variable. So in rows, I am going to put the university role in rows, and in columns, I am going to put the hometown. Okay, so let's see if there is a significant relationship between university role and the hometown of the respondent. So I have put university role in rows, and I have put hometown in columns. So after clicking this, you will find the value over here, chi-square test of independence value over here. So we can also use another one, that is Cramer's V test over here. So it will open like this. So here this table shows the value of chi-square test of independence, and this table shows the value of Cramer's V. Okay, so you can find Cramer's V value over here. So this is how you can create the chi-square goodness of fit, and another is chi-square test of independence. So using Jamovi, you can find the value simply, and after finding the value, you can interpret the results as well. Okay, so now I'm gonna show you how to interpret the result in Word file. So here I have the Word file, and here I'm using the Jamovi app. Okay, now first let's write the title over here. That is chi-square goodness of fit test. Okay, so this is the title that I've written. Now let's use variable. So for the variable, we are going to use university role. Okay. Now let's write the research question. So my research question will be, are the observed frequencies of university role equal to the expected frequency? Okay, so this is the research question that I've made. Now let's set the null hypothesis. Hypothesis. Okay, so my null hypothesis will be, there is no significant difference between the observed frequencies and the expected frequencies of university roles. Okay, so this is the null hypothesis that I have written. Now we are going to copy the table from Jamovi. So let's give the title first. So observed frequencies versus expected frequencies of university roads. Okay, so this is the title. Now let's move to Jamovi. So as we have created here the goodness of fit value from Jamovi, so let's copy this and let's paste over here. Okay, so we have chi-square value is equals to 149 and p-value is less than 0.05. So in this case, we reject the null hypothesis and conclude that the observed and expected frequencies are different. So this is how we are going to find chi-square goodness of fit test. Now let's move on to another, that is chi-square test of independence. Okay, so for this, we are going to choose variable 1, that will be our university role. Next, for the variable 2, we are going to choose hometown. Okay, now research question will be, is there a significant relationship between the university roles and the hometown of respondents? So this is the research question that we have created. Now let's move to our null hypothesis. Okay, so null hypothesis will be, there is significant association between university roles and the hometown of the respondents. Okay, so this is the hypothesis that we have set. Okay, now we are going to say table 2, and this will be association between the university role and hometown. Okay, so this is the table 2, and we are going to insert a table over here. So the x square value for from our Jamovi is 1.14. So we are going to write 1.14 and n is equals to 248. Okay, now let's move to DF. DF is 1, and then p-value is 0.285, and Cramer's v-value is 0.0678. So from the table, we have chi-square value equals chi-square value equals to chi-square value equals to 1.14. We have p-value p p-value is equals to 0.285, 0.285, which is greater than 0.05, with Cramer's V equals to 0.678. So in this case, we fail to reject null hypothesis and conclude that there is no significant association between the university role and hometown of the respondents. Okay, so this is how you interpret the results. So as you can see in first table where we observed chi-square goodness of fit test. So here we found that the p-value is less than 0.05, which is 0.001, so which is less than 0.05. So in this case, we reject the null hypothesis and conclude that the observed and expected frequencies are different. So this is the result for chi-square goodness of fit test for the variable university role that we did in Jamovi as well. Now moving towards the chi-square test of independence for the two variable. One variable is university role and another variable is hometown. So here we set the null hypothesis, and then from Jamovi we found the value of chi-square test of independence. So here we can see that the chi-square value is 1.14 and p-value is 0.285, which is greater than 0.05, with Cramer's v-value 0.0678. So in this case, we fail to reject null hypothesis and conclude that there is no significant association between the university role and hometown of the respondent. So likewise, you can create or you can find the chi-square goodness of fit test, and you can find the chi-square test of independence value using the Jamovi. And after using the Jamovi, you can interpret the result similar like this. So this is how we perform chi-square test using the Jamovi. So now we are going to move on when to use chi-square test. So it is used when you have two or more categorical variables, when you are counting the frequencies within defined categories like gender against educational level or gender against educational subjects. You can choose anything which has two or more categorical variables. So it is also used to see if the observed frequency in one category are independent of the observed frequency in the other category. So when we need to find the proportion and independence, the chi-square test is used. So this is how we can perform chi-square test, and through this presentation I have tried to explain about what is chi-square test, how can we perform chi-square test using Jamovi, and when to use the chi-square test. So this was my presentation about chi-square test. So thank you for listening to me. Thank you so much.